So your 13.3 part 2 lesson starts off by reviewing what we did in 13.3 part 1. So for this example, you may see different numbers that I'm showing than what's in your notes. Just change them to the ones that I'm working with so that way they're much easier to work with. And then again, you can just follow along. So with this example, you're finding the rule and the 12th term given that the a sub 3 is negative 4/3 and a sub 7 is negative 64 over 243. Again, if yours are not the same as mine, just change them to be the same numbers. So the first thing that we're going to have to do is find R. Remember, R is your common ratio. So in order to do so, we are going to use the formula that we worked with in 13.3 part 1. So to find R, we're going to use a sub n is equal to a sub 1 times r to the power of n minus 1. We are going to substitute in the a sub 7 for a sub n and the a sub 3 for a sub 1. Your n minus 1 is just going to become the 7 minus 3. So this is going to turn into your negative 64 over 243 is equal to a sub 1, which is negative 4/3 times r to the power of n minus 1. We're going to use 7 minus 3 because those are the two terms that we're working with. From here, simplify your power. That's going to give you negative 64 over 243 is equal to negative 4/3 times r to the power of 4. You want to move the negative 4/3 over, so we're going to divide each side by the reciprocal, multiply each side by the reciprocal, or just divide. So that's going to be 3/4, and it's negative. So that's going to cancel out on the right side, and then on the left side, you're going to multiply by negative 3/4. A negative times a negative is a positive. Your 4 goes into 64 16 times. And then your 3 goes into 243 81 times. So this is just going to give you 16 over 81 is equal to r to the 4th power. We're looking for r, not r to the 4th power. So we're going to have to take the 4th root of both sides in this case. So this one is going to turn into r is equal to the 4th root of 16 is 2. And the 4th root of 81 is 3. So your r is 2/3. Now that you have what r is, you need to find a sub n. So to find a sub n, we're going to use the same formula. That's it. A sub n is equal to a sub 1 times r to the power of n minus 1. So use one of the values that they give you. I'm going to work with the a sub 3 is equal to the negative 4/3. And that's going to turn into negative 4/3 is equal to a sub 1 times r, which we said is 2/3, to the power of n minus 1, which is 3 minus 1. So this simplifies to give us negative 4/3 is equal to a sub 1 times 2/3 to the power of 2. The 2/3 squared is negative 4/3 is equal to a sub 1 times 4 over 9. Again, we got to move the 4/9 over to get a sub 1, so we're going to multiply by the reciprocal. So we're going to just flip the fraction and multiply by 9/4 on both sides. Cancels out on the right side. On the left side, you do have a negative times a positive, so your answer is going to be negative. Your 4's simplify to be 1's. Your 3 becomes a 1, making the 9 a 3. So it's 3 times negative 1, which means your first term, or a sub 1, is equal to negative 3. Now that you've found both of these, we can write our rule. To write our rule, we need both r, which is 2/3, and a sub 1, which is negative 3. To plug these into a sub n is equal to a sub 1 times r to the power of n minus 1. This is going to give us a sub n is equal to negative 3 times 2/3 to the power of n minus 1. So that's part of your answer that it's asking you for, because that is your rule. The next thing that you're finding is a sub 12. So to find a sub 12, we're going to use the negative 3 times 2/3 to the power of 12 minus 1. The 12 minus 1 is 11, so that's a sub 12 is equal to negative 3 times 2/3 to the power of 11. You have to apply that power to both the numerator and the denominator. So that 2 is going to become 2 to the 11th power. The 3 becomes 3 to the 11th power. If we simplify that, the 2 to the power of 11 gives us 2,048. The 3 to the power of 11 gives us 177,147. If we simplify these, that 3 is going to become a 1. The denominator of that fraction becomes 59,049. So we multiply straight across, and we get that a sub 12 is equal to a negative 2,048 over 59,049. So the next thing that we're going to look at is the partial sums of geometric sequences. So just like when you worked with partial sums with arithmetic sequences, you're going to have a formula to work with your partial sums of geometric sequences. Do not get the two confused. You need to pay attention to the wording with these. For geometric sequences, if you're asked to find the partial sum, you're going to use the formula S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. Keep that in mind, because you're going to use it on the next examples. For your next example, you're asked to find the partial sum of each of the following geometric sequences. For the first one, it tells us that there's going to be 7 terms in the sequence. You have 1, 4, 16, and then this 4,096. So you need to find your common ratio, or R. So what are you multiplying by in order to get each of these terms? Well, 1 times 4 is 4. 4 times 4 is 16. The 16 times 4 would be 64, and so on. But your common difference here, your common ratio here, or R, is just 4. Your first term that we're working with, so a sub 1 is 1. You have to find n, which it gives it to you in this term, or in this case. So n is 7, because it tells us 7 terms in the sequence. So we're going to use our formula, which is just that S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. Plug your values in. That's going to give us 1 times 1 minus 4 to the 7th power over 1 minus 4. The 4 to the 7th power changes this to be S sub n is equal to 1 times 1 minus 16,384 over 1 minus 4, which is negative 3. I'm going to just pull this up here to give us S sub n is equal to 1 times negative 16,383 over negative 3. A negative divided by a negative is a positive, so we just are going to have S sub n is equal to 1 times the 16,383 divided by 3, which is 5,461. 1 times anything is itself, so a sub n is equal to 5,461. For example B, we are finding the partial sum with the rule 2 times 3 to the power of I. We're starting with 5, ending at 12. So our n can be found, just like we did with our partial sums of arithmetic sequences, by doing the top minus the bottom plus 1. So that's going to give us 12 minus 5 plus 1, which is 7 plus 1, and that means that n is 8. Recognize your R from your given rule, which is the 3, and then find a sub 1. To find a sub 1, we're going to take the 2 times 3, plug in the 5 for I. Your 3 to the 5th power gives us 243. If we multiply that by 2, that gives us 486 for a sub 1. So use your formula. You're going to have S sub n is equal to a sub 1, which is 486, times 1 minus r, which is 3, to the power of n, that's 8, over 1 minus r, which is 3. This is going to simplify to give us 486 times 1 minus 3 to the 8th power, which is 6561, over 1 minus 3, which is negative 2. Subtract on the top of your fraction. You're going to be left with 486 times negative 6,560 divided by negative 2. Double negatives turn to positives. 2 goes into the 6560 3,280 times. So you're multiplying that 3,280 by 486, which is going to give us 1,594,080. For example C, you need to write in your rule of 8 times 1/2 to the power of n minus 1. You're starting at 2, ending at 18. So first thing we can do is find n. To find n, we're going to do 18 minus 2 plus 1. That gives us 16 plus 1, which means n is 17. Next, find a sub 1 by plugging the 2 in for n. So it's going to give us 8 times 1/2 to the power of 2 minus 1. That's just 8 times 1/2 to the first power, which is 8 times 1/2. So a sub 1 is equal to 4. Now use your rule, or not your rule, but your formula. So you're going to have S sub n is equal to a sub 1, which is 4, times 1 minus r, which is 1/2 to the power of n. That's going to give us 17 over 1 minus 1/2. So that 1/2 to the 17th power is what we're going to have to simplify first. This is going to give us 4 times 1 minus the 1/2 to the 17th power, we said, is going to be 1 over 131,072. And this is all over 1 minus 1/2, which is just negative 1/2. From here, if you wanted to rewrite this as division, you could. So that way it's not that confusing and you don't have a fraction over a fraction. But I want to subtract that 1 minus 1 over 131,072 first. So that 1 has to turn into the 131,072 over itself. When you do that and then subtract 1 from it, you're going to get 4 times 131,071 over 1,000, and this is negative, sorry, 131,072 divided by negative 1 over 2. With this, we can keep change flip. Your negative divided by negative would also become positive. So that's going to give us 4 times 131,071 over 131,072 times 2 over 1. This 2 is going to simplify to a 1. The 131,072 is going to turn into 65,536. So if we multiply 4 times 131,071 over 65,536, this is going to give us S sub n is equal to, this 4 can turn into a 1. This will turn into 16,384. So 131,071 over 16,384. For the last part of your part 2 notes, we're working with infinite series, which means if you look at this formula or this pattern that we have here within this sequence, you will see the infinity sign on the top of your sigma. This means that it goes on for forever. Another indicator on this is your ... at the very end, without there being a number after it. This just means infinite. Okay, so anytime you see that ... or that infinity sign on top of your sigma, it means that it's infinite. Okay? There is a different formula for you to use when it asks you about your infinite geometric sequences. That formula is going to be this one down here, which is that S sub n is equal to a sub 1 over 1 minus r. So this one's a little bit easier to work with than your partial sums. So if we use this formula and look at some examples, for our first one, we have 2 2/5, 2 over 25, 2 over 125, plus ... Remember that ... means infinite. It goes on for forever. Look at your change that's happening here. So your common ratio, or r, if you multiply that 2 by 1/5, you get 2/5. The 2/5 times 1/5 is 2 over 25. 2 over 25 times 1/5 is 2 over 125. So r in this case is 1/5. Your a sub 1 is 2, because that's your first term. And we only need a sub 1 and r in our infinite series formula. So plug these values in. This is going to give us S sub n is equal to a sub 1, which is 2, over 1 minus r, which is 1/5. That 1 is going to have to turn into 5 over 5. So that gives us S sub n is equal to 2 over 4/5. I don't like working with fractions within fractions, so I'm going to rewrite using division. That's going to give us S sub n is equal to 2 over 1 divided by 4 over 5. Remember, when we divide fractions, we keep, change, flip. So this is going to become 2 over 1 times 5 over 4. Your 2 is going to become a 1. Your 4 becomes 2. So that gives us 5 over 2 for our answer. For example B, we have a series that's going from 4 to infinity with the rule -2 times 7 to the power of I. First thing we got to do, we know what r is because that's the 7. So r is 7. Other than that, find a sub 1. So we're going to have -2 times 7 to the power of 4. The 7 to the 4th power is 2,401. So that's going to give us -2 times 2,401, which means a sub 1 is -4,802. Now that we have a sub 1 and r, use your formula. S sub n is equal to a sub 1, which is -4,802, over 1 minus r, so that's 7. This simplifies to give us -4,802 over -6. A negative divided by a negative is a positive, and this simplifies by dividing each of these numbers by 2 to give us 2,401 over 3. For your last question, you're working with the rule 2/3 times -2 to the power of n minus 1. You're starting at 3, going to infinity. So because there's that infinity, we're going to use that S sub n is equal to a sub 1 over 1 minus r. You identify your r first. That's the -2. Next, find a sub 1. So that's going to be 2/3 times -2 to the power of 3 minus 1. The power of 3 minus 1 becomes the power of 2. The -2 squared is 4. The 4 times 2/3 gives us an a sub 1 of 8 over 3. So if we plug this in to our formula to find S sub n, we're going to have 8/3 over 1 minus r, which is -2. double negatives turn to positives, and you're going to have 8 over 3 divided by 3 over 1. Keep, change, flip, and this becomes 8 over 3 times 1/3, which gives us S sub n of 8 over 9.